Day 10, AP Physics, page 313, problem 46. This is essentially a work energy problem. The basic work formula, work equals F dot D, cosine theta. Theta is 0 degrees. The force propelling the runner forward is in the same direction as the motion, so it'll be the angle is 0 between those two quantities. Cosine of 0 is 1, so it's just work equals force times distance. Now, the runner is going to gain kinetic energy because they did work. She or he did work. So the initial kinetic energy, if you start from rest, is 0. The final kinetic energy is the change in kinetic energy. So let's just look at the final kinetic energy here for a second, which will be delta Ke. So delta Ke will be equal to 1/2 mv final squared. So in this case, they gave you that. Delta Ke, well, although we don't have the mass of the person, let's see what happens here though. The final velocity is 9.9 meters per second. I'm going to let you plug in 9.9. I'm just going to take the cheap way out right now because I don't have my, well, I have my calculator, but I'm going to make that 10 meters per second. So basically I have 1/2 m times 10 squared, rounding off a little bit. That will be, in terms of m, 50 m, because 10 squared is 100, and 1/2 of 100 is 50. That m there stands for the mass of the person, so I'm doing this in terms of mass. I'm pretty sure it's going to cancel out. So I'll go back up to the work function now, or the work equation, and the work done is the force propelling the person times the distance. Now, let's look at the total work done. The total work done, well, is supposed to be 50 m. So I'm going to plug that in to W here, and I'll go off to the right. So I plugged it in, I get 50 m equals the force that's propelling him. The force propelling him is 1.5 times the body weight. So 1.5 times the weight of the person. Well, the weight of a person is mg. So 1.5 mg times the distance that the force acted upon the person. Well, you can see here maybe now already that the mass will cancel out. That's not meters, that's mass. And if I do some rounding off again, if g is 10, I have 1.5 times 10, I got 15. So what I have here right now is 50 equals 15d. Now if I solve that for d, well, that's just going to be 50 over 15. So it'll be 10 over 3. Isn't that 3.3 to 2 sig figs? 3.3. The distance is 3.3 meters. That's the distance at which the force had to act. Now it says that each stride was 1/3 of a meter. So basically, so the total acting force had to act over 3.3 meters. Basically, you just divide 3.3 by 1/3 of a meter. That's what? That's 10 times 10 strides. So n has to be 10 strides. In other words, you take 3.3 divided by 1/3, it's going to be 10 strides to get up to this speed under these conditions.